ASCII renderings come in a variety of flavors and have many different creative uses. Beyond logos and stylized headers, entire games like Dwarf Fortress and more recently Stone Story were rendered completely in ASCII characters. ASCII art has been incorporated into Hollywood movies like The Matrix, and you can actually watch Star Wars Episode 4 on the command line entirely in ASCII art. I had started making a tutorial on how to write an ASCII shader when I thought of something. Could we have ASCII art where the characters could move around? If we could, what would that allow for? So in this video, we will explore this new type of ASCII renderer and the things it makes possible. This is an ASCII shader or renderer I developed where the characters can move around. They have a fixed area where they can oscillate like particles in a solid object. In this clip, I'm sitting in front of my webcam. The only light in the base video comes from my cell phone's flashlight mode and the faint light from the computer screen. The basic ASCII shader or filter involves taking a pixelated version of a video or texture and replacing each of those pixel cells with a character that approximately matches the brightness level of that cell. So you would have an array that sorts the index of characters that you've chosen specifically to match different brightness levels, and they would ideally be stored in order of brightness in the array. To get the pixelated video, you sample a video at a reduced resolution by doing something like UV equals floor of UV times 100 divided by 100. Then, if you use this new UV to sample your texture, you've effectively downscaled or reduced the resolution of the image. So you get a pixelation effect, or you have cells of pixels that all have the same value. If you find the grayscale of each of these cells, you get a luminance value. To use a luminance value to access our character array, we scale it up so the values are from 0 to array length, and then we use floor and int to get the integer value. You can use that value to select the right character from the array, and you have your basic ASCII shader. The hard part is allowing those characters to move outside the grid boundaries. To do that, we need each of the neighbors of a given cell to help out in drawing the cell's chosen character. So the Voronoi algorithm does exactly that. I've covered the Voronoi algorithm in great detail in part 1 of my Voronoi Edges series, so if you're not familiar, you can check that out. Here, all we need to know is that the process involves a double for loop. In that, we construct the floored coordinates for each neighbor and find that neighbor's offset position, which will allow for movement. A minute ago, I showed you how we can use a floored and scaled UV to get a downscaled or pixelated version of a video. We do the same thing here for each neighbor in this double for loop. The coordinates we use each round are the current cell's floored value plus the neighbor direction we are drawing for. We scale that back down, fix the aspect ratio, and we're ready to access the video. So it's almost identical to the basic ASCII shader. Once we can access the video for each neighboring cell, we can get the luminance for that cell of the video and then the ASCII character for that cell of the video. Once we have that, we can add a random offset for each cell so the characters can be displaced. Lastly, we need to mask everything outside that character so that we don't draw all of the texture and end up with a jumbled mess. So whatever we do to the character in terms of movement, we also do to a squared shaped SDF box that we use to mask things. That's the basic idea. I could see something like this in an art installation or maybe a film, but could it work in games? Even the basic ASCII renderer generally makes things harder to see. A lot of information like distant objects or fine details, which are important for navigating a game, generally get lost. Adding movement, size changes, and even random color, my first thought was that it would just make the problem worse. At some point during the process, I realized you don't have to have all the characters moving all the time. You can choose how things move, where things move, and what causes that movement. From that perspective, this effect actually expands into a whole vocabulary that allows for a lot of interesting effects that you couldn't easily render with a basic ASCII renderer. The most obvious thing to me to use this technique for was as a form of blur, since after all, if there's one thing this shader is definitely good at, it's making things harder to see. So we can make it so that the characters move around more and get more blurry as the size increases. This works okay, but the characters of smaller sizes can overlap with ones that are a larger size, and this is because the basic Voronoi function doesn't sort things based on size. It's just drawing based on whatever cell we're on in that double for loop. On the other hand, we can use a basic radial gradient to drive the blur, which can give a look like a lens getting blurry around the edges. This doesn't suffer as much from the size issue since there's a gradient where cells near each other are generally about the same size. An even cooler idea I had was triggering the movement and blur as a depth of field effect. I built a small ray march scene that returns a distance value from 0 to 1 in its alpha channel. I use that to drive both the SDF blur and the movement of the characters. I also recolor things based on distance to make things more clear. This makes it look kind of like an underwater scene. Another cool thing is that once you have something like this set up, you get fancy titles like this for free. I use the SDF versions of the characters as the texture that the ASCII function samples. Since the lowest luminance value is just a blank character, we can easily make out the letters. The version with the drop shadow looks very classy here as well. And it's all text really. Look at my phone. This is my phone showing my contacts list. Isn't that wild? I can almost see it being used as an interesting censoring effect. Another idea I had where you sample just a 2D SDF is a shockwave effect. So imagine an action game where there's a large impact and the characters jump out of place in waves across the screen, almost like the fabric of the rendered reality gets disturbed when the force or impact is high enough. Also, if we wanted, we could easily use a mouse or anything else that the computer can sense to shoot holes into the ASCII renderer so the characters disappear. Maybe they can spawn back in later. This could be used as a cool damage effect as well. I tried to turn this into a burning paper effect, but I didn't get too far. So those are new ideas, but they don't stretch things too much. This last idea might. I made another simple ray marched scene, but this time I return an ID for each object. Then based on that ID, I animate the movement and scaling of the characters differently. So we could say one object is fire, object 2 is water, and object 3 is rock. So it's like the ASCII characters are now particles moving as you would expect based on the material. So imagine a very low budget game where all of the materials are encoded as just IDs, but when it hits this post-processing step, then all this extra simulation is added on top. So I guess my question to all of you after seeing all this is, what do you think? Can this be considered an ASCII shader that manages to add at least as much detail as it removes? Let me know in the comments, and also any other feedback is generally appreciated. And that's all for now. I'll see you in the next one.